Hello everyone, welcome to my new lecture series. This is Vignesh, working as an assistant professor in Department of Mechanical and Mechatronics Engineering in SNSCE College of Engineering. And in my lecture series, we are discussing about the basic problems in engineering thermodynamics, especially in first law of thermodynamics, where we can use closed system and open system. In my previous videos, we have seen a problem based on the closed system as well as the open system. And today's video also, we are going to solve the problem based on the open system. Okay, so write it down. A 12 kg of air per minute is delivered by a centrifugal air compressor. The inlet and outlet condition of air are the velocity has been given as 12 meter per second, pressure as 1 bar, velocity has been given, and specific volume, right? So 0.5 meter cube per kg has been given, and velocity at outlet. Okay, so C2 has been given, pressure has been given, specific volume has been given, and the increase in enthalpy of air passing through the compressor is 150 kilojoule per kg, and heat loss to the surroundings is 700 kilojoule per minute. So what we need to find out as motor power required to drive the compressor. Okay, so we need to find out the work done and the ratio of inlet to outlet pipe diameter. Assume that inlet and discharge lines are at the same level. Okay, so this you need to find out in the calculation. So write down the given data. This is a centrifugal compressor, okay, where the air has been compressed and given to the other one. Okay, so here inlet and outlet conditions has been given. So write it down. M is equal to mass flow rate has been given, so 12 per hour has been given, so 0.2 kg per second, and velocity as 12 meter per second, pressure has been given, so specific volume has been given as 0.5 meter cube per kg, and velocity at outlet has been given 90 meter per second, pressure has been given 8 bar, so you have to consider as Newton per meter square, so 8 into 10 to the power 5 Newton per meter square, specific volume as 0.14 meter cube per kg, and change in enthalpy has been given as 150 kilojoule per kg, and heat transfer has been given as 700 kilojoule per minute, and you need to convert it into as a kilojoule per second, so that is 11.67 kilojoule per second. That much of heat energy is transferred from the system to the surroundings. Okay, so what you need to find out? We need to find out work done and the pipe ratio, diameter ratio. Okay, so first write down the steady flow energy equation first. Q plus M into H1 plus C1 square by 2 plus G into Z1 is equal to W plus M into H2 plus C2 square by 2 plus G into Z2. Okay, so rearrange those terms. You will get W is equal to M into H1 minus H2 plus C1 square by 2 minus C2 square by 2 plus G into Z1 minus Z2 plus Q. Okay, so substitute all those terms in that equation. M has been given, enthalpy has been given, C1 and C2 values has been given, or substitute all those terms in that equation. Q is also be given, so substitute all those terms. You will get work done as 42.46 kilowatt. Okay, so this much of motor power is required to compress the air. So this is we are talking about the centrifugal compressor. There is no work done by the system. We need to give the work done to the system. So 42.46 kilowatt of power we need to give to the motor or to the compressor in order to compress the air. Okay, this is what the interpretation. And the second one is we need to find out the ratio of inlet to outlet pipe diameter, that is D1 by D2, and here we need to talk about mass flow rate, that is M is equal to specific volumetric flow rate divided by specific volume. This is the equation. So if you want to calculate the volumetric flow rate, the formula is area into velocity. So substitute that m is equal to a1 into c1 divided by specific volume, that is v1, is equal to a2 into c2, that is volumetric flow rate, divided by specific volume. Okay, here rearrange these terms. a1 by a2 is equal to c2 by c1 into v1 by v2. So if you rearrange this, this equation comes like this. Okay, and substitute all the velocity and specific volume, and you will get a1 by a2 as 26.78. you need to find out the diameter ratio. So d1 by d2 the whole square is equal to 26.78, and d1 by d2 as 5.175. This is the ratio of inlet to outlet pipe diameter. Okay, so so in this lecture series we have seen problems related to the first law of thermodynamics, especially on open systems as well as the closed systems. I hope you find it useful, and thank you for watching.